In this example, we're going to go ahead and look to verify this trigonometric identity. And so, of course, we have two sides to this equation. We have this left side, which has a fraction and also this cotangent of beta. And the right side over here looks like just a single trig function, cosine of beta. So probably it would be much easier to take the more complicated side and try to reduce him down to just a cosine beta than it would be to try to manipulate this cosine beta into looking more sophisticated like this left side. All right, so on this left side, it looks like we have a cosecant of beta and a secant of beta and a cotangent of beta. So we have all these functions. Let's go ahead and write them in terms of sine and cosine to get going. So 1 plus, and we can rewrite cosecant of beta as 1 over sine of beta. And then the secant beta in the denominator we can write as 1 over cosine beta. And then we'll subtract from that. Let's see, cotangent will end up being cosine of beta over sine of beta. And we would like that to end up being cosine of beta when we're all done. Okay, so it looks like we have ourselves a nice complex fraction over here. So let's go ahead and first just look at this numerator. And we have 1 plus 1 over sine beta. Let's go ahead and get common denominators here and change this 1 into a sine beta over sine beta. So sine beta over sine beta plus 1 over sine beta. And that's all over that 1 over cosine beta. And from that, of course, we are subtracting this cosine beta over sine beta, and that's going to equal, and hopefully our cosine beta here. Okay, so when we have complex fractions, remember, or any fraction for that matter, fractions kind of tell us that we're trying to do some division. So we have this numerator up here divided by this denominator down here, and whenever you divide fractions, remember, you're really multiplying by the reciprocal. So I'm going to take this fraction that's in the denominator and I'm going to take its reciprocal. And then I'm going to multiply it by this numerator that's up here. And basically everything else just kind of gets written and comes along for the ride. Okay, so here's where we are right now. And of course we have this equals, and we're trying to make it look like this cosine right up here. Okay, let's go ahead and distribute this through. So it looks like we have a sine beta times cosine beta all over that sine beta plus cosine beta over sine beta and then minus this cosine beta over sine beta. And at this point, we're just about done. This is going to wrap up fairly nicely. So you probably saw already that the plus cosine beta over sine beta and the minus cosine beta over sine beta will cancel one another out, so those are gone. And for this fraction over here, it looks like we have some multiplication, and this is being divided by the sine beta. It looks like our sine betas will cancel out right there, and we're left with just that cosine beta. And so we're trying to make this left side look like cosine beta because that was the right side, and now it does. So we have gone ahead and we have verified this trigonometric identity. So let's go ahead and recap what we did. We started by changing this left side into just everything in terms of sine and cosine. We worked with this complex fraction. We went ahead and got common denominators up here and then did this division by multiplying by the reciprocal. Once we distributed this through, we saw everything just started canceling from then. And here's our cosine beta. And there is this example for verifying trigonometric identities.